means the measuring angles, or you can say is the branch of mathematics that deals with the study of relationship between the sides and the angles of any triangle. Yeah. So for example, if I have a triangle, if you take this right angled at B. So here we we have three sides, right, in a triangle. This side, which is opposite to the 90-degree, is known as the hypotenuse, is the longest side of any triangle. And BC, on which this 90-degree is, known as the base. And this is the perpendicular. Also, we call it as adjacent side if we are considering this as an angle. So this will be adjacent, this will be opposite, and anyhow this is hypotenuse. So if you consider the other angle, what we have here, angle A, in that case this will become opposite, this will be adjacent, and hypotenuse anyhow will be hypotenuse. The side opposite to 90-degree is hypotenuse. On the basis of these three sides, we have 6 trigonometric ratios like sine, cos, tan, cot, cosecant, secant. These are the ratios on the basis of these angles. So sine is always opposite upon hypotenuse. Cos is adjacent upon hypotenuse. Tan is opposite upon adjacent. Cot is 1 upon 10 basically. Cot is 1 upon 10, so it will be the ratio will be just inverse of tan, that is adjacent upon opposite. For cosecant is 1 upon sine. Because it's 1 upon sine, its ratio will be the reverse of sine. So it will be h upon o. Secant is 1 upon cos. Because this is 1 upon cos, the ratio will be inverse of cos, that is a upon h. Basically h upon a. Yeah. Yeah. So trigonometry, as I just told, that it measures the relationship between the sides and the angles of any triangle, basically a right angle triangle. And in right angle triangle, the three sides, they will be named as hypotenuse, opposite, and adjacent. Hypotenuse will be fixed, the side opposite to the 90-degree, which is the longest side of any right angle triangle. The opposite and adjacent keep on flipping depending upon the angle which you are dealing with. If it's in this figure, if you see the angle A, the opposite will be BC and adjacent will be AB. If you're considering angle C, for that opposite will be AB and adjacent will be BC. The opposite is basically that side which is opposite to that angle which we are considering. And just adjacent means the one which is just next to it. And hypotenuse anyhow is the side opposite to 90-degree. Make sense? So these things we need to remember, like sine, these ratios, that sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, tan is opposite upon adjacent, cot is inverse of tan, so adjacent upon opposite, cosecant is inverse of sine, so it is h upon o, and secant is 1 upon cos, which is h upon a. That is hypotenuse upon adjacent. Now, if we take one example, this becomes more understandable. One second.
Nice.
Yeah. So this is the question. So let's make a triangle. Triangle ABC, right angle at 90. So okay, like this. So let this be A. this be B, and this is C. This is 90 degree as per the question. Because they have told take angle A as 90. So AB is 6. So AB is 6. AC is 8. Yes. And BC is 10. Correct. Now they are saying find sine B, cos B, and tan B. So if we're considering B as the angle, this will be opposite. This will be adjacent, and this will be hypotenuse. And if we are considering angle C, then this will be opposite. This will be adjacent, and this will be hypotenuse. Hypotenuse will always be the side opposite to 90 degree. Now it's easy. Sine we already know.
Yeah.
Sine is opposite upon hypotenuse. So if you see sine B, which is this, opposite is AC. So AC upon hypotenuse, which is BC. So this will come out to be 8 upon 10. Cos B, as cos is adjacent upon hypotenuse, and in this case adjacent is AB. So AB upon BC, because BC is the hypotenuse, and this will be 6 upon 10. Tan B, tan is always opposite upon adjacent, and the opposite side here is AC. AC upon AB for angle B. So this will come out to be 8 upon 6. Now sine C, sine again the same, opposite upon hypotenuse, but this time we are considering angle C. If you see here, for angle C, the opposite is AB. So AB upon hypotenuse anyhow will be the same, BC. So this time the sine of C, the sine of this angle will be 6 upon 10. So force the sine of angle B is 8 upon 10, and the sine of angle C is 6 upon 10, because the opposites are different. Similarly, cos C will also come different, though it's though it's adjacent upon hypotenuse, but this time adjacent will be different. For cos C, adjacent is AC. So AC upon BC, hypotenuse same. So this will come out to be 8 upon 10. And tan C, anyhow tan is always opposite upon adjacent. The same is the case here. Opposite would have changed. So opposite is over here in this case is AB, and adjacent is AC. So this will come out to be 6 over 8. Last time it was 8 over 6. Yeah.
All right.
So this is how we
I'm
able to
sorry,
find.
sorry. What was that voice crack?
Yeah. Now there are more, as I said, there are 3 more ratios which though haven't been asked in this question, but we can figure it out. So let's find secant of B. The secant of B, as we know, secant is nothing but 1 upon cos B, is the inverse of cos, and cos is adjacent upon hypotenuse, so this will be hypotenuse upon adjacent. And now for B, the hypotenuse is BC, and adjacent for angle B is AB. So this will come out to be what? 10 upon 6. And cosecant B, cosecant
Uh,
is inverse of sine, and because it's inverse of sine, so it will be hypotenuse upon opposite. So hypotenuse is anyhow BC, and opposite for this is AC. So this will come out to be 10 over 8. Similarly, we also have cot, the, the sixth ratio, cot B, which is 1 upon tan B, because cot is always inverse of tan. And because tan is opposite upon adjacent, so cot will be adjacent upon opposite. So for B, adjacent is AB and opposite is AC. So this will come out to be 6/8. We can also find out secant C. Secant C will be 1 upon cos C. And
All right.
cos C we already had find out. Cos C was here 8 upon 10. Because cos C is 8 upon 10, it will be 10/8 because it's inverse. Cosecant C. Cosecant C is 1 upon sin C. And 1 upon sin C we already had figured it out here. Sin C, which is 6 upon 10. So this will become 10 upon 6. And
All
cot
right.
C is 1 upon tan C. So 1 upon tan C means, because tan C is 6/8, so this will be 8/6, the inverse of that. So we figure it out, the 6 trigonometric ratios for both the angles B and C. Yeah, this was the question, and this is how we figure it out. All of them. Make sense? Let's take another example.
All right.
Yeah, so this is another example where we have a triangle right angled at B. Okay, let's make it. Yeah, yes. So this is your B, right angle 90. You can have A, C here. Now AB is 10. So AB is given as 10. Yes. BC is 24. Okay. And they're saying find out AC. Yes. Okay. No problem. First of all, AC is nothing but hypotenuse, because opposite to 90° is always hypotenuse. So in this case, because it's a right angle triangle, we use Pythagoras theorem. With the help of Pythagoras theorem, we can find out AC. So according to Pythagoras theorem, AC square is equal to AB square plus BC square, right? So AC square equal to AB square plus BC square. So let's put in their values. AB is 10, so 10 square plus 24 square. Yeah, and this will come out to be 100 plus, what is 24 square? You can always find out. Basically, maybe 576. Let me check. Yeah, 576. So this will come out to be 34. This is BC state. Okay. Now we can add them up. So this become 676. And the square root of this 676 will be basically maybe 26, but yeah, you can always try. 6 times 6 is 36. 3. 6 times 2 is 12. 350. 6 times 2 is 12. 1, 2, 5. So yeah, we were right. So this will come out to be, AC will come out to be square root of 676, and that will be 26. So we able to figure it out what is find AC they have asked. So that is 26. This is how we do. And they also have asked us to find out sine A, cos A, tan A. Let's figure it out. Now because we have all the sides, it should be easy to figure it out. Yeah. So sine A. So this is angle. So opposite will be this. Opposite, adjacent, and as I said, hypotenuse is this. And if other is the triangle, if you consider this as the angle, so opposite will be this. This will be the adjacent, and hypotenuse anyhow will be the fixed AC. But in this case, they are asking us to find out sine cos tan of angle A. No problem. We'll find out. The sine of A, sine is what? Sine is opposite upon hypotenuse. So for A, opposite is BC and hypotenuse is AC. And BC is given as 24. So 24 upon 26. Cos A. Cos A is adjacent upon hypotenuse. So adjacent in this case for A is AB. So AB upon AC, and AB is 10. So 10 upon 26. Tan A. Tan is opposite upon adjacent, and opposite is BC for angle A,
All right.
and adjacent is AB. So this will be 24 upon 10. Now let's find out sine C also. Though they haven't asked, let's find out. Sine C, same, opposite upon hypotenuse, but this time opposite will be different. For angle C, the opposite is AB. So AB upon AC, hypotenuse fixed. So AB is 10, so 10 upon 26. Cos C, same, adjacent upon hypotenuse, and adjacent in this case is BC. So BC upon AC, so BC is 24, to 24 upon 26. Tan C, opposite upon adjacent, and for C, opposite is AB upon BC, which is the adjacent side. So this will come out to be 10 upon 24.
All right.
Yeah,
So these are the fundamental rules.
yes. So
All right.
what all we covered up today was the 6 trigonometric ratios and how we can figure it out if the two sides are given in a right angle triangle, how we can find the third one using Pythagoras theorem. Any doubts all
Not
clear?
ish, but like